In this example of a transmission system, we will activate study case number 1, named low flow. To activate the study case, we will rely on the project overview window, which is a new feature introduced in PowerFactory version 15. The project overview window will appear in the main application window and displays an overview of the project. This allows the users an easy interaction with the key project components, such as study cases, operation scenarios, variations, and grids. Therefore, right-click on the study case number 1 and select Activate. You will notice two single-line diagrams appearing. The two diagrams represent the same system, but with a different degree of detail. The overview diagram is a single-line diagram without detailed graphical information of the substations. That is, substations are illustrated as composite nodes. In this particular case, the 225 kV substations are represented with rectangular composite nodes. The 90 kV substations, on the other hand, are represented with circular composite nodes. In the other single-line diagram, you will notice a more detailed representation on the substations. We will now color the single-line diagrams according to voltage levels. For that, we will use the diagram coloring button located at the top of the toolbar. You will notice three priorities that can be set to the diagram coloring scheme. We will use in this case the one specified as Other. We will select then according to topology and based on voltage levels. The preview will show then the actual color representation that will take place. By clicking on the Color Settings button, the user will have the possibility of selecting between a wide range of colors available. You will now notice the two single-line diagrams colored according to the voltage level specified. To perform a low flow, click on the Calculate Low Flow button located at the top. In this first example, we will select the AC low flow balanced and we will consider the reactive power limits. On the active power control options, we will select them as dispatched, where the balancing will be done by the reference machine. We will click therefore on Execute. You will notice that the diagram coloring has changed. This is, the coloring is now based on the low flow solution. If you now click on the diagram coloring, you will notice in the low flow section the Other specified as results and according to voltages and loadings. If you reset the calculation, then the coloring will be then reset to voltage levels. If we perform once again the low flow, we can have a very quick view of the results from the single line diagram by simply pointing the mouse to one of the result boxes so that the expanded dialog appears. The same thing can be done, of course, on the other single line diagram. It is sometimes also convenient to represent graphically the direction arrows of the active power flow. In order for us to enable this option, we should click on the Layers button and select the direction arrows. The direction arrows option should be then placed on the visible side. The configuration of the direction arrows can be seen by selecting the configuration and then selecting the results, direction arrows, so that we know the direction representation. In this case, it corresponds to the active power. We will notice then in the single line diagrams the direction arrows appearing corresponding to the active power flow. The low flow balancing in this case is performed by generator S2. If we double click on the generator and go to the low flow settings, we will see that it's set as a reference machine. Another easy way of detecting this is to edit relevant objects for calculations and to select the synchronous machines. Go to the low flow tab page and filter them by bus type. The one selected as SL is the one then being used as a slack. We can also mark this generator in the graphic by selecting the entire row, right mouse button, mark in graphic. We'll have then the option of marking the generator from the available graphics. We'll simply choose one, say OK, and it's marked. Suppose that we want to make the balancing now by the group of machines located in substation number 5. To achieve this, we must then create a secondary control. The easiest way of creating the secondary control is to do it from the single line diagram. Make a rectangle selection on the generators. Hold down the Control key so that we select also a bus bar. On the selected elements, right mouse button, define power frequency control. This automatically creates a power frequency controller in the model. And it will be based then on the generator selected and also on the bus bar selected. There will be several options for the active power distribution according to nominal power, individual active power, or according to dispatched active power. We will leave it in this case according to nominal power. There are also other options for the control mode, so we can select also power frequency control. We will select OK. If we now perform again the low flow with the same settings and press execute, you will notice no difference on the results. That means that although we specified a secondary controller, reference machine is still assigned as a generator in the substation S2. In order to enable the secondary controller, we must change the setting then from the low flow command. In the active power options, select then according to secondary control. This will then consider the secondary control that we implemented in the previous step. If you now press execute, you will notice a difference in the power flow results. In order to compare the results in an easier way, we will use the comparison results tool. This can be enabled by pressing the comparing of results button. Since we have already a low flow solution, it will prompt that it will save the results as case A. We will now perform another low flow, but we will return the settings as dispatched, meaning that it will be balanced by the reference machine, that is generator S2. Once we perform an execute, and since the comparison of the results is enabled, PowerFactory will prompt to save the current calculation as case B. What we now see in the single line diagrams is a relative comparison of both cases. The settings of the comparison results can be changed by clicking on the Edit Comparing of Results button. Here the compare mode, as well as the case A and B, can be changed. To exit the comparison mode, just simply click again the Comparison of Results button. When analyzing the behavior of power systems, there is sometimes the need of evaluating future network conditions, such as evaluating the impact of commissioning a transmission line or a power plant, or the impact of refurbishment or decommissioning of equipment. For such purposes, PowerFactory offers the concepts of variations and expansion stages. In this particular transmission system example, there are two variations, Wind Park West and Wind Park East. The two variations with the corresponding expansion stages are dated in time, meaning that the expansion stages are applied according to the study case time. If we therefore change the study case time to a date previous to one of the expansion stages, we will see this reflected in the model. To change the study case time, simply right-click, Edit, and change to a corresponding date. Since the Wind Park East variation has a later date than the one assigned, it will not be reflected in the model. If we now perform a low flow, the low flow is carried out without this Wind Park. If we put a later date than the one being used by Wind Park East, then it will be considered again. And so it's very easy in PowerFactory to make very rapid comparisons of low flow results.